Hello viewers, this is Karthikeyan, Professor of Electrical Engineering. In this video, I am going to explain you how to write the transfer function of the given mechanical rotational system. Consider the system shown in figure 1 in which the moment of inertia J1 and J2. J1 is associated with the elements B12 and K. J2 is associated with the elements B, B12 and K. The angular displacement at J1 is theta 1. The angular displacement at J2 is theta. The applied torque is T. Torque is applied at J1. For this given mechanical rotational system, you are supposed to find the transfer function theta 1 of S by T of S or theta of S by T of S. Look at this video very carefully. I will tell you a small shortcut so that you can straight away write the final answer without applying the torque balance equation, differential equation governing the system, and then Laplace equations. First, I will tell you how to write the transfer function theta of S by T of S. I will tell you that denominator part first. So denominator is very simple. First you should write the elements associated with J1 and then elements associated with J2 minus square of elements connected in between J1 and J2. So the elements associated with J1 are J1 B12 K. So you should write it as J1 square plus B12 into S plus K. The elements associated with J2 are B, B12 and then K. So you should write J2 square plus B12 plus B into S plus K minus square of elements connected in between J1 and J2. There are two elements connected in between J1 and J2. They are B12 and K. So minus B12S plus K whole square. This will be the denominator part. Numerator part will be you are supposed to find theta of S by T of S. Theta is the angular displacement which is in J2 side. Applied torque is at J1 side. So torque is one side, displacement is another side. If it is so, you should write whatever the elements connected in between J1 and J2. So the elements connected in between J1 and J2 are B12 and K. So the numerator part will be B12 into S plus K. So in this way you can write theta of S by T of S. Now I will tell you how to write theta 1 of S by T of S. Here, if you look at the given mechanical rotational system, theta 1 is at J1, applied torque is also at J1. So you have displacement and applied torque, both are at J1. If it is so, leave the J1, consider the J2 alone. Consider the J2 alone to write the numerator part. Whatever the elements associated with J2, that will come in the numerator. So numerator will be J2 into S square plus B12 plus B into S plus K. This will be the numerator. In the denominator part, there is no change. You can write whatever the denominator you have written in the theta of S by T of S. So elements associated with J1, that is J1 S square plus B12 S plus K into elements associated with J2, that is J2 S square plus B12 plus B into S plus K minus square of the elements connected in between J1 and J2. That is nothing but B12 into S plus K square. So in this way you can straight away write the final answer without applying the torque balance equation, differential equation governing the system, and then Laplace equations. I hope you understand. If you have any doubt, please let me know through comment box. I'll clarify your doubts. Thank you.